to our final session of talks for today on the mezzanine stage. If we haven't met yet, I'm Rachel. I'm on the Engineering Design Systems team at Figma.
And I'm Megan. I'm on the Collab Tools team at Figma. We're your hosts for the mezzanine stage today. We're excited for this last session, but I know you guys are thinking, how can there possibly be more incredible talks?
Well, we're about to show you. Up next, we have Setor Zilevu, who will take us on a deep dive into the world of AI evals. He'll show us they're more than just a raw technical tool. They can actually better ground our work and user experience.
Please give it up for Setor.
Hello, everyone. My name is Setor Zilevu. So before we get into the topic of AI and evals, I have a mini confession to make to you all. And that is, for over the last 5 years, I've been cosplaying as a researcher. So truth be told, I always thought I would be a neurosurgeon growing up. But I quickly found out that I'm terribly afraid of both blood and needles. So I realized that that wouldn't be the best career path for me. And so this led me to ultimately decide to pivot away from healthcare into computer science, where I thought I'd be staying far away from medicine. But unfortunately for me, right before my undergrad graduation, my father suffered from a stroke. And I remember my world took a 180. And I think a lot back to how I found that moment, the uncertainty, the fear, and also the realizations of the complexities of healthcare and the patient recovery process. When I reflect back, I think about how that single moment really altered my trajectory. I decided to pivot back into healthcare, and I stayed as close as I could to medicine and dedicated both my master's and my dissertation on trying to figure out how we could use artificial intelligence to improve patient outcomes. And so it's from this experience that I've held on to this deep belief that families deserve access to high-quality care through technology. So very early on in my career, I helped build one of the world's first cyberhuman systems for stroke survivors, which you can see here on the screen. And at the time, the goal was simple: allow patients to receive high-quality therapist feedback at home using interactive apps and wearable sensors. And so in order to do this, we needed to pilot this with real stroke survivors. And now, this brings us to John. John was one of our first participants at our study at Emory University. John suffered from a mild stroke, which left his left arm weak, and he joined our study hoping for one thing: a glimpse of what getting his mobility back might feel like. And on the screen in front of him was one of the apps that I built. It walked him through his rehab exercises and gave him feedback on how he was progressing. And during our pilot at Emory University, it kept telling him similar things. He's getting better, and his movements are improving. And John was thrilled by the type of feedback he was getting. But behind him, a therapist was watching the same screen, and her face said something completely different. She saw what the system couldn't. John was overcompensating. He was extending his shoulders to make up for his weak arm. And the therapist catches that instantly, but our system didn't. Now, if she hadn't been in the room, John could have practiced the wrong patterns for months, thinking he was actually healing, which would have actually made his recovery process 10 times harder. What was interesting was that our system did exactly what we asked. It measured movement, it tracked progress, it gave feedback, but it still almost sent a patient down the wrong path. And because of that, I think and I reflect, I never asked the one question that truly mattered. Did our definition of good match the therapist? When we look back, we see that our model was accurate. Technically, it passed all of our test cases, but it was also wrong. And ever since that study, we ultimately end up improving our system to drastically match the expectations of the therapist. And I've thought a lot about that gap between what we initially built and versus what John actually needed. And today it makes me wonder, how many AI products are out there right now that look accurate but aren't doing what people actually need? And how do we decide what AI should do, not just what it can? So fast forward now a little over a decade, and I'm still working on solving that core problem. Across my career, from Virginia Tech to Google to Meta, and now Figma, that exact same question keeps popping up in the form of AI evals. So now I'll be honest with you all. When I first heard the words AI evals, I was genuinely confused and I thought it wasn't for me. It sounded like something that was reserved only for machine learning scientists. And I know I'm not the only one who has felt that way, because I guarantee you there's been someone in this room who has been in a product meeting where engineers leaned forward and said, we need to improve our eval coverage or our benchmark data is saturated, and you just nodded your head. You didn't raise your hand, you didn't ask what it meant, you just wrote it down in your notebook so you could secretly Google it later. And then when you Googled it later, it didn't help. And you probably looked a little bit like Michael Scott over here. So now, if you've ever felt that way, don't worry, because by the end of this talk, you're gonna know exactly what evals are, how to do them, and why you're the best person in the room to lead. Now, before we continue, I want us to quickly do an exercise together. Imagine you prompted your favorite AI design tool to generate an output from the text that you see here on the screen. So create a homepage for a running mobile app. Now imagine design X is your first output. Now imagine design Y is your second output. There are no right or wrong answers here, but raise your hand if you think design X is better. Now raise your hand if you think design Y is better. Look around the room. We're split. If I ask each of you to explain why you voted the way you did, every single person will give me a slightly different answer. And that's because we're human. Our unique backgrounds and life experiences impacts how we perceive quality. In the past, we might have looked at this room and said, we have a problem, nobody agrees. But in the world of AI development, that disagreement isn't the problem. That disagreement is the data. What we just did right there, that's the foundational spark of an eval. An eval simply means taking human disagreement, distilling into a shared measurable criteria, and using that criteria to systematically steer the product's output. That's it. So why does it feel so complicated sometimes? And I think that's because there are two myths that we've been telling ourselves that aren't true. The first myth is that evals are strictly an engineering problem. We assume that because engineers build the model, they must own the measurement and therefore the definition of good. But look what we just did. The hard part wasn't just about generating the output. The hard part was also evaluating whether the output was good and being able to articulate why. So now you might be thinking, okay, we define what good is once and we're done. But human expectations evolve. What feels like magic today will feel like a baseline requirement a month from now. And because the human context is always constantly shifting, our definition of good must shift with it. When we look at historically how we've built products, it went through the process of ideate, visualize, build, and ship. And it worked because they were deterministic. However, with AI, that predictability has been shattered. You can enter the exact same prompt 3 times, and you're going to get 3 different outputs. And so because of this, our approach to how we evaluate and measure quality needs to shift. Now, building products is an evolving process to define what the product should become and how we can continuously steer it there in the direction that we want. Quality is no longer verified at the end. Quality is directed throughout. We now become the orchestrators. Our job sits between the model and the value provides for people. And along this nonlinear journey, our decisions, what to prioritize, what to measure, and where the model needs to get better at directly determines what the product becomes. So now, how do we actually do this? I want to show you someone whose work over the last 20 years closely resembles AI evals. She just never called it that.
Upfront. Interwoven with these fabrics are a mesh of tiny sensors that monitor the baby's physical properties.
Oh, Lord, what is he? What is he doing?
Well, it's Mozart, Robert. Can you blame him? The important thing is that the student tracker anticipated the change and alerted you.
Oh, no. Cookies. I gotta get cookies.
You do not need cookies. As I learned quite painfully last night, any solution involving cookies will inevitably result in the demon baby.
Combustion imminent? What does that mean?
It means fire, Robert, for which the suit has countermeasures. I suggest you extinguish the baby's flames before he trips the sprinkler system. The flame ring.
So, many of you have seen The Incredibles and have seen Edna before. But notice what she did when she was building the suit and working with Robert. She didn't start with a spec, she started with one question. And that question was, what does Jack Jack need? Then from this, she continuously built a suit that was adaptable. She watched his movements, observed, learned, and realized he had powers she never anticipated, and his powers were always evolving. But here's the thing that most people miss about Edna. She wasn't just observing Jack Jack, she was directing the outcome. Every time she learned something new about his powers, she made a decision on what needs to improve next. The suit actually molded into his behaviors. It became what she told it to become. Now here's where it gets interesting. Jack Jack isn't an AI model, but his behavior is probabilistic, especially when he's upset. You can't predict what power you use, you can't write a spec for it, but somehow Edna was able to anticipate all of this and steer the suit and him in a direction that she wanted. We follow that same process when we think about how we evaluate successful AI products. We have to define intent, set success criteria, measure, learn, and repeat. And all of this happens continuously. You become the one directing the process. So where does this loop actually run? It happens across 3 layers: human, auto, and UX, which we have a unique ability to influence. Remember earlier when none of us could agree on which output was better? That's because we never set the criteria for what we defined as good. Without that criteria, everyone is guessing, which makes it very difficult to track. So now here are 3 approaches that we can take to steer the model towards what actually provides value for people. Can you guys hear me now? Cool. So the first approach answers the guessing problem head on. If everyone is guessing, the fix is to write it down what good means and put it into human hands. That is a human eval. You create the criteria and you turn it into a rubric. And then you hand that rubric over to expert graders whose job it is to look at the outputs and score them. This is the moment where good stops being an opinion and becomes measurement. Human evals takes a shared criteria into numbers you can track, compare, and improve. The grader's score now becomes the ground truth for you and your team. But human evals has a limitation. Graders are expensive, and grading takes a lot of time. And so there's a limit to how we can effectively scale this. And so this brings us to our second approach, which is auto evals, using AI to grade AI. You take the rubric, the ones you have your graders calibrated on, and you teach an LLM how to apply it. So now you're no longer just scoring dozens of outputs quickly, you're now scoring thousands automatically. However, with auto evals, you're only as good as the human graders it learns from. So if your graders aren't calibrated, you're no longer scaling judgment, you're just scaling noise. So now this brings us to UX evals, and this is the third approach that aims to solve the blind spots for both human and auto evals. With human and auto evals, the graders score the outputs in a vacuum, and so do LLMs. But the people who use AI products don't live in a vacuum. They bring their own workflows, their context, and that context isn't always captured in human and auto evals. And this is where UX evals aims to fix that. You put the product in front of real users and watch them using their natural context to see how you can improve the model. Now, this might sound a lot like traditional research, and on the surface it is, but the core distinction is the gap it closes to how we actually improve model quality. The signal you get from real users feeds directly into model improvements. And now, when it comes to understanding these 3 layers and actually helping improve model quality, who has spent years tracking and emerging user needs over time? Who will spend their entire careers defining objective quality standards and translating human behavior into product signals? Researchers and designers, understanding user needs, defining what quality looks like, and measuring whether you're hitting the mark. This is an engineering bottleneck. This is core research and design. We aren't learning a new craft. We're simply applying our existing skill set into a new technical frontier. And so the question now becomes, how do we take our specific expertise and use it to shape the foundational model itself? When you see, evaluating AI products doesn't require new skills. It's just renaming the ones we already have. So expertise such as defining the North Star, understanding disagreement, servicing user needs, and synthesizing findings becomes writing the success rubric or calibrating graders, defining the eval sets, or triaging failure modes. It's the exact same craft. It's just now applied at the model layer. So now I want to walk us through one full cycle of this loop at Figma from start to finish. So the loop starts here with intent. Before you measure anything, you have to decide what the model actually needs to be good at, and just as important, where to focus on first. You can't improve everything at once. And at Figma, this is where I spent a lot of my early efforts, where I helped the team prioritize which use cases our agent needed to be good at, and really nailing our eval sets. And so now, once you know what you're aiming for, you have to define what good means in a way that other people can apply the same way you would. And this is where I wrote our initial rubric and calibrated our graders. And calibration is the key word here. It's not enough to just write a rubric down. You have to get your graders aligned so they're scoring the same output consistently. And this is what turns success from one person's opinion into a shared language, something that's consistent and something that you can actually measure. And then once you can measure, measurement looks different depending on the direction you want to steer the product. And so for one example from human evals, be able to measure the content quality or response quality or prompt success. You analyze these results and how well they're performing across each of these different dimensions, and you actively surface those gaps you're noticing to the engineering team to prioritize. And this is where it all starts to pay off, where measurements turns into improvement. Every test that we've surfaced showed us something differently, specifically the high frequency and high severity failure modes, the things that broke often and the things that broke badly. Those went straight to our engineers' hands for concrete signals for what we needed to fix. And as they made those fixes, we saw the scores go up, and that's when the flywheel begins to happen. And over time, we start to see the impact of this work reflected and noticed by leadership. This is our chief design officer reacting to the trajectory of our improvements. And what I noticed early on in my time at Figma is how much our direct recommendations and quality fixes are highlighted to our exec team. And that's the shift I want us to really start to prioritize. How we can shift from influencing the product indirectly to shaping it strategically and directly through model quality. And so through this work, I've started to realize that we have far more power to shape AI than we think. We have 4 distinct levers to influence how a model behaves, and the first is through system prompts. You shape how the model behaves in production, its tone, its guardrails, what it will and won't do. The second is through eval design. When you design the eval, you actually design what good means, and everything the model measured flows against the bar you set. So whoever defines the rubric defines the target. And the third is through data sets. You decide what the model learns from, what it gets judged on, and how you make sure it reflects on what actually users need, not just what is easy to collect. And the fourth is through capabilities. You determine what the model can actually do for people by shaping the tools and the context that it's giving. 4 levers which we're uniquely positioned to own. So now I want to leave you all with this. We talk a lot about how AI is changing the world, and it is, but AI doesn't know where it's going. It only knows where we've been. Someone has to point it forward, and that someone is us. We spend our career sitting between what exists and what should exist. Let's be the architects of what comes next. Be sure to own the loop. Thank you.